Great. So welcome to those online. Hopefully you can see the slide pack and you can hear my voice. Do send us a message that you can hear us, and we're just about to kick off. Okay. Firstly, very, very warm welcome to Arts University Bournemouth, and specifically to the plastics. There you go. Specifically to the Plastics Research Centre set up here in the last year. So we haven't done a full year yet. My name's Dr. Christian McLenning. I'm the director of the Research Centre, and we've also got a few members here of the team, which I'd like to introduce to. So importantly, we've got Dr. Louise Dennis, who's the curator of MoDiP. So we'll be talking to us first, which we look forward to that. And we've got some MoDiP team members as well. Do you want to give us a wave so we can catch up with you in a break? So Shannon and Pam, thank you for joining. Also, we've got Unidas is our co-director. So Unidas comes from a social science background at the University of Manchester and works with us as co-director at the Research Centre. Our research fellow, Erato, with a really key role in the centre with a heritage and conservation background as well. Just been joined by a new colleague, postdoc. Here she is. Yeah, so with heritage and material science expertise. Yeah. So I'm describing these because I think it's really important to contextualise. We are welcoming our two PhD students who are going to do a workshop with us later, Penny and Joanne, so look forward to that. And with more of an arts angle as well. So beginning to see the different dynamics here. We've got Sharon and Ollie, who help actually make it all work. Fantastic. They lead the centre as well. We've got Dr. John Burgess at the back. So John and I are product and design engineering backgrounds. So again, a real diversity of different people involved in the centre. Who else have I missed? Valerie organises this all in terms of the research of the university as well. So just really briefly, you're at Arts University Bournemouth. We are specialists in art design only, so architecture, fine art. We've got a film studio just down the road. So it's all about creativity, performance, media. And we've got a big gallery space in the centre where we've welcomed all sorts of artists and designers in. But in an exhibition for Zaha Hadid work a little while ago we were talking about. So it's a little bit unusual to have this centre here, but we've got the museum as well. Can I just do a little call out for who's in the room, not necessarily individually, but groups. So I know we've got a group from Revolution Plastics at Portsmouth. Give us a wave. So crikey, there's a whole bus load. It's fantastic. Thank you for coming. We've got some Exeter. Where are you from? University of Exeter. Thank you. That's good to see. And we've got the excellent. Thank you for coming. Always useful. I'm just trying to get a picture. Dorset Museum. Yes. Well done. Thank you, sir. Who else have we got that we haven't? I know we've got the Zaha Hadid Foundation team, and so we went up to do a visit with you recently. So thank you for coming down. That's really appreciated that. Any other kind of groups? I think we've done. God, hello.
Well, the film student, we're making a film for plastic research.
You are?
We are indeed.
Thank you for that. So as you know, the centre was set up thanks to Research England. So the Research England funding, we were awarded the Expanding Excellence. So we were awarded £1.64 million for the 5 years they run them for, which is fantastic. For a small institution, you can imagine how important. And I was reflecting on why we were successful in the bid and what are the ingredients that I think they saw in the beginning of this proposal. And expanding excellence, well, the excellence was already here. So I think colleagues in MoDiP, our Museum of Design in Plastic, so hopefully you get a chance to see that today with Louise, our curator, had already established a real centre for excellence. If you managed to join us for lunch, we would have been in the Innovation Centre, the orange building designed by Sir Peter Cook, with incubators and startups, particularly focusing on helping companies develop new products. So we've got loads of rapid manufacturing, lots of prototyping kit, and colleagues like John here with the experience of mass manufacturing and design challenges using materials. So this was the kind of the starting point of bringing together some of these principles to see what we could do. So our bid had two strands deliberately, makes it a bit complicated, but I think it's why they went for it. The first strand is looking and understanding what is happening in terms of our heritage and our artifacts made of plastic, which of course is the MoDiP's expertise and centre, seeing how things are changing over time. But then we thought, oh, there's also an opportunity as we're helping new and emerging designers and engineers choosing the right materials appropriately. It's a difficult challenge. What can we learn from these artifacts that we've got in our history? What can we take forward in terms of knowledge base and help advise the appropriate use, the sensible and wise use of plastics going forward? And that's where I think we've got the twin themes. The money gave us the ability to hire some new staff, difficult in current times, but we're really pleased. So we've added to the design and the curation expertise already here. We've added that with heritage and materials science and expertise that we could bring in. So Erato and Elena and our PhD students. So we've grown our expertise and our ability. As you know, E3 and Research England want a return. So we've got to, that's our plan, and it's what we're promising to do. We've got to develop our knowledge base. We've got to share our knowledge. We've got to collaborate and explore. We'd like to support industry, and particularly in the region, choosing the right materials, testing the right materials. And we're also going to be developing programs and courses that can help and support curators or people who work in the museum sector who are confronted with artifacts that maybe are polymers and plastics, and bring our expertise and advice more broadly out to that world as well. So we've got quite a big remit. It's a challenge to balance it all, but I think we're going to manage it. So one of the aims is, this is our very first symposium. We're going to do one every year. This is the very first one. And I think getting to know you getting to know us, the opportunity to talk and think about potential collaborations, think where it might be a bid putting together in the future. So really, this is an opportunity to network and hear what other people are working on and see if it sparks ideas, see if it perks your ears up and you think, actually, oh, yes, we could add something there. Now, I know there's a lot of expertise in this sort of hard sciences and engineering in plastics, but it's interesting, the Revolution Plastics here. I think the social impact, I think the heritage world, I think we all need a bit more joined up thinking. And this feels like the right starting point, a group of people. And I know there's others who've already started on this journey, and we'd love to join you as well. So really very collaborative. And that's how I'd like to see it. And I'd welcome your contributions today and afterwards. Set up things, come and visit us again. We'd be delighted. So bit of CPD, we're going to do some courses. We're looking at a master's in the future with heritage sciences as well, and bit of consultancy work because we've got some testing equipment now thanks to the funding. So lots on the horizon, I think. I'm just checking the time. It's time. Okay. I think if we're going to run through the speakers, I think we've got about 15 minutes with a couple of questions at the end of each one. We'll try and keep it fairly to time, if that's okay. And then we'll have and then we'll rotate through. Does that sound okay? Good. How are you on time?
Yes, go ahead.
Shall we start? Shall we kick off? Right. So I think, look, I think our first speaker is Dr. Louise Dennis, who's head of MoDiP. Oh, curator of MoDiP. Would you be okay, each of the speakers, rather than me rambling along, if you could just give us a quick overview of you, that would probably be more accurate as well. Is that okay? Right. So over to Louise, thank you.
Yes, I'm Louise Dennis. I'm the curator at the Museum of Design in Plastics, which is here at AUB. It's upstairs in the library. There will be an opportunity to come on a tour. So whilst half the group are having doing the workshop later, some people can come on the tour. If you've seen it already this morning, because I had some guests this morning, you don't have to come up and see MoDiP again, but you'd be very welcome. So I'm just going to basically do quite a quick whiz through an historical and contemporary look at the use of plastics using the MoDiP collection as examples. It's not the definitive history of plastics by any means, but it hopefully will give an overview of what we're talking about when we're talking about objects designed in plastics. So I'll start by just introducing MoDiP to you if you don't know who we are or what we do. We are an accredited museum here at AUB. That means that we're seen as a bona fide museum who does certain things to look after the collection in a very specific way. And we've also been awarded designated outstanding collection status by Arts Council England, which sees us as being of national importance because nobody else is collecting in quite the same way as we do. The collection is wide and varied, as you can imagine. Here are just a few of the objects that we have in the collection. We've got about just under 14,000 objects, and they touch all aspects of life. We collect objects that are either wholly made of plastics, have significant plastics components, so their functionality is really important because of that bit of plastic that's part of them, and also objects that help us understand plastics. So thinking about archival material and our growing reference library as well that we have. The work at the museum is focused on exploring the value of plastics when they're used appropriately, but we also acknowledge the negative impact of plastics materials that they have on health and the environment as well. But we're really interested in how, learning from the past, using the collection, we can help manufacturers, designers and consumers make better informed choices, whatever those choices might be. So today there is an understandable condemnation of the overuse of plastics and their impact on the environment. These kinds of images are images that we see a lot, and these are the images that a lot of people associate when they think about plastics. So they're seen as cheap, they're seen as rubbish, throwaway, expendable, basically bad news. And this position of negativity has been reached because we see this mismanagement of plastics. We see the waste, we see it blowing in the streets, we see it in the oceans where it shouldn't be at all. However, our relationships with plastics as a material family over time has been very diverse and turbulent, and it's had different perspectives generated by different people at different times, depending on where their position is in the world and their financial status, perhaps. But if we put that into context in terms of sort of the history of plastics, hopefully you can read those, the text on there. It might be a bit small. So plastics as a family of materials have been with us for a long time, much longer than is often recognised. Each material within this family has its own biography, characteristics and properties. And if we think of them as being sort of separated into three distinct classifications of plastics, we start with the natural plastics, which are materials that can be moulded in their natural form. These include horn, tortoiseshell and shellac, for example. And then we go on to the semi-synthetic plastics. Those are made of a chemically altered natural material. And these start to be developed in the 1860s, which is perhaps earlier than people imagine. And then there are the synthetic plastics, and these are materials that are entirely laboratory made, and they include phenol formaldehyde, which was developed in 1907, polymethyl methacrylate, polyamide, polyvinyl chloride, and polypropylene, to name a few. And then we also have composite materials, which sometimes straddle the synthetics and the semi-synthetics, and they can include glass reinforced plastics, carbon fiber composite, which, as I was saying earlier, was developed in 1963, and it's quite a modern thinking material, modern material we can imagine. So it's actually, that's, as a material, has been around for quite a long time. I've shown you some materials. It's not an exhaustive list of all the materials that are out there, but hopefully it's given a bit of context of the number of materials that are around and how long they've been around. So at the beginning, plastics were basically created as substitutes for other materials. Those materials that were perhaps perceived as having a greater value, more integrity. And this ball, it's a billiard ball, so it's sort of larger than life here, is made of cellulose nitrate, and it represents the beginning of the explosion of semi-synthetic and synthetic materials. It's kind of like the Big Bang of plastics materials. It's the very, very beginning. So the story's well told, but if you don't know it, there was a call for responses to find a replacement for a dwindling natural resource, elephant ivory, to produce billiard balls and snooker balls. And the answer was this new material, amongst other options that were put forward. The call to replace the ivory wasn't based on the fear of the extinction of the elephant at all, but for the fear of the loss of ivory, basically. So it was driven by economics rather than ecology. So you might think that this is saving the elephant, but it's not. It's saving billiards and it's saving snooker. But it's really the birth of the family of materials as we know it. The development of new materials inspired newer materials, each one building on what had come before. Some semi-synthetic and synthetic materials were discovered by accident, and others were invented very purposefully. So it's a really interesting family of materials when you think of it in that way. So as I was saying, that these are materials very early on that are mimicking other materials, those that were expensive, luxury, derived from endangered animals and plants. So I've mentioned ivory before, but we also have tortoiseshell, which comes from the sea turtles, and endangered woods, such as ivory, ebony, and all of these materials can mimic those other materials. So yeah, that's fine. I lost my place, but that's fine. So as new materials were discovered and created, they became the favoured resources for many manufacturers. They took over from other materials at a very rapid rate. Companies use them to demonstrate their being state of the art or at the vanguard of design. And in the early 1920s, a journalist wrote of one particular material, bakelite, or phenol formaldehyde, that we can see here, as invading almost every field of commerce and manufacture, of art and science. So the notion that less than 20 years after its discovery, in 1907, a material could have had such an impact on so many aspects of life, it really must have felt that it was invading. It took over from so many other options. At the outbreak of the Second World War, 1939 to 1945, Plastics were seen as essential to the war effort. They were used in groundbreaking technologies such as radar systems in aircraft, and bubble cockpit canopies in the fighter planes, as we have here. So all sides were focused on the development of plastics into their use for conflict. New synthetics were developed to fill the gaps created by a shortage of natural materials. This shortage may have come about because of workforce shortages, because people were fighting and off at war, or because materials were basically behind enemy lines. So we had to find new ways and new materials, such as the nylon used in parachutes rather than silk that was coming from Japan. This focused development and production of new materials before and during the Second World War created a surplus of materials that didn't necessarily have a natural place to settle in peacetime. So there was a rise in the use of plastics in so many objects. The sort of dramatic and passionate relationship that many manufacturers had with plastics was publicly experimental. So people were using materials that they didn't necessarily know what properties they had, or whether they would survive being played with if they were turned into toys, or if they were the right material to be turned into a waterproof jacket. So there was a lot of experiment, and that experiment led to people mistrusting some of the materials and the objects that they were made into. So it's quite an interesting look at how we have relationships with materials. To counter the swamping of products that were either technically ill-conceived or chemically unstable, European companies placed significant investment into the production of quality products and quality objects made of materials that were fit for purpose. Particularly during the 1940s, plastics firms, so the people who were creating the materials, had their own design studios, and this included BIP, British Industrial Plastics, who established a design advisory service as well as a product design unit. And those two departments were for use both within the company, so the designers within that organisation, but they also opened it up to external organisations as well. So they were keen that people were using, manufacturers were using the materials in good ways, in the right production processes and for the right purpose. So World War basically created a very dark and depressing world, with rationing touching many aspects of consumption. And to reignite economies, societies across the world were encouraged to consume products to aid economic growth, to maintain jobs and improve lifestyles. The make, do and mend mantra of the Second World War was tossed aside, and disposability of ephemeral objects and less ephemeral objects with designed-in obsolescence was encouraged. Plastics materials played a significant role in the boosting consumerism, and it is at this point that we first see the sort of disposable side of plastics coming through. Manufacturing products in such high numbers makes each unit very, very cheap. And if the product is cheap to purchase, it's deemed easy to replace and therefore easy to dispose of. At this time, it's seen as a moment of positivity, that disposability was a positive. We think of it perhaps as a negative now. But the white, clean products that made the life of the housewife, as it was at the time, much easier by reducing the drudgery of housework. And the future at this point was a promised utopia where the world is clean, it's fresh and it's bright. Think about the 1950s here, it saw a rise in the number of objects that were made of plastics. And these products were colourful and joyous and brought a brightness that was much needed after the darkness of war. So fun and joy are part of the story of plastics. The 1960s saw another significant era for plastics. They offered a way of conveying some of the most fundamental values embraced by the pop culture at the time. And pop culture had two focuses: an aesthetic for expendability, or an expendable aesthetic. So the former offers the idea of disposability, whilst the latter could easily be disposed of. So, for example, the inflatable plastic chair, PVC chair, versus a paper chair. But in contrast to this celebrated disposability of the earlier period, plastics went through the ecological outcry of the 1970s and once again were considered to be inferior to natural materials. An awareness of our dependence on fossil fuels was really highlighted by the oil crisis of 1973, and the effect of this time had a real impact on plastics production, and it saw explorations increase into bio-based feedstocks, so bioplastics. And these explorations were quickly forgotten when the oil market opened up again and we went back to the status quo of using fossil fuels more readily. So more latterly, if we think about the 1980s, plastics gained a more high-tech image. The key elements of pop culture re-emerged, and at this point it was under the umbrella of postmodernism. And this embraced plastics for the almost infinite range of possibilities, with the ability to carry so many different connotations within different objects. It's at this period that the term circular economy is coined and the recycling triangles are introduced. So the 1980s, there's so much going on. Most plastics are recyclable, but some are more difficult. Those that cannot be melted down and reused, like virgin materials, are known as thermosets, as opposed to thermoplastics, which can be reformed. And they have to be processed in ways that are expensive, and that makes it less cost effective to recycle, so they tend not to be. And then recycling, if we think about recycling, it becomes even more complicated when you've got more than one material in each product. Okay. So there's so many different factors involved when thinking about recycling, and I can talk through some of those a bit more later. So today, plastics are used for a hugely wide variety of products, some good, some less good, and some completely unnecessary. There are some vital life-saving, life-supporting uses of plastics, including within the medical sector, as well as objects like these. These objects are particularly looking at how water can be transported and filtered in areas where water isn't as readily available as it is in the West. And then some contemporary material and product innovations have an eye on the environment, such as the production of biodegradable products. Here we've got the sort of easily recognizable plastic cup that we're all seeing when we go out to pubs or clubs and things. So the idea is that would biodegrade very easily, but the componibile in the center, the pink componibile, is also biodegradable, but how do we go about degrading that product? It's quite a large object. So just to finish up, I just want to say that, you know, we've had a really brief look at plastics. It was very quick and a bit of a whistle-stop tour. And we've touched on some of the positives, some of the negatives, and we've had some examples that are being used today, as well as those that are in the past. We've seen that they've been with us for a long time, and they're very much part of museum collections, not just MoDiP, but other collections as well. And newer materials, such as those that are bio-derived or biodegradable, are also becoming part of collections, as we'll hear about later with Panos' talk. So these collections help us to discover more about the use and misuse of plastics. And it's the aim of MoDiP and the Plastics Research Centre to help consumers, designers and manufacturers, and also museum professionals to, and to be slightly punny because I love a pun, but to look carefully at the objects that they're using or looking after, to value and care for them when we do use them. So just as this lady is acknowledging how beautiful her washing up bowl is, but also we need to be disposing of them responsibly when they've gone beyond use. So hopefully that's some of the work that MoDiP can do, and also the research centre. And just to plug our website, it's got to be done at the end. We've got lots of information and resources on our website, so the QR code will take you there, but it's modip.ac.uk. Thank you ever so much.
Questions for Louise while we set up for, or we can do some at the end. Well, okay, thank you. Right. Okay. So I think it's just about.
It's just a click.
Yeah. So there you go. So welcome. So over to Cressida.
Hi everyone, my name's Cressida. I'm Deputy Director of the Revolution Plastics Institute at the University of Portsmouth. This is the Director, Steve Fletcher. And I'm also an Associate Professor in Arts and Sustainability. I used to work in the music industry, and then I did a degree in biological sciences and a PhD in hard science in molecular pathways in cancer cells. And then I started postdocing and bringing my sort of previous life into my science life. And I suppose I work a lot at the interface between the arts and the sciences, and, you know, utilising different approaches. And I'm absolutely, you know, very, very keen on transdisciplinary thinking. Thank you so much for inviting us here today. It's one, I love being in an arts environment, actually. And spending the morning in MoDiP, it really stimulates us to think in different ways. And I hope that some of the team who've come along sort of appreciated that as well. So yeah, thank you. So Revolution Plastics Institute, what do we do? We umbrella all the plastics research that goes on in the university, but we also have a core team. We have the people, we always think of them as people who actually sort of work full-time, work in the office of the institute. And basically our business is about urgently confronting the global plastics crisis through inclusive and solution-focused research and innovation. I have to say, I would you know, add to Louise said, you know, the sort of negative framing is around the fact that we can see plastics in the environment. Actually, our business is to, you know, really think about the impact of plastics on people and planet and what we might be able to do about that. Sadly, now we find plastics wherever we look. We find microplastics literally wherever we look. You know, virgin snow, Mariana Trench, you know, your unborn baby, your testicles, your blood and your brain, you know, everywhere we look, your water, your food. So it really is a global crisis. A lot of the work I do uses a community-based and participatory research approach. And so that means the work is done in the community, with the community and for the community. Ideally, you work with the community to identify what the research questions are in the first place, but it's super hard to write that in a funding bid. Just saying, it's one page. We're going to work with the community and then go from there. And I've put the in brackets because, you know, the traditional sort of definition that you might have in your head of community is a community, a village community or something. But as you'll hear later on in the presentation, we work with communities of industry, we work with communities of policymakers, we work with lots of communities of academics, as well as grassroots communities. So why would you want to do participatory research? Why would you want to involve these people in the first place? I mean, firstly, they've got enormous amounts of knowledge and social capital. So you really want to integrate that into your research design, your research process, and your research findings, especially if you're designing interventions to improve the situation. And the other really important thing is to make sure that what you're doing is relevant and is likely to have impact in that particular setting, so that we're not sort of parachuting in, thinking, oh yeah, this needs to happen here, this needs to happen there, doing it, going away, and then 6 months later, you know, the whole thing's disintegrated because it wasn't really fit for purpose. And when we do this work, I like to use arts-based methods. So things like visual arts, music, storytelling. And why use these kind of methods? Because they're really inclusive. They're not dependent on certain literacy levels or expertism. They kind of break down disciplinary silos, they break down research hierarchies, and they're quite engaging, and they can be fun as well, which is important, I think. But I always think to myself, they reach the parts that other methods don't reach, both in terms of when you're carrying out the research, but also when you're sharing the research findings. So I'm going to talk about a particular project, which is when I first started working on plastics, actually, sustainable transitions to end plastic pollution. And we worked with two communities. We worked in an informal settlement in Kenya called Nakuru, and we worked in a city in Bangladesh called Sylhet. And we identified community champions in both those settings to work with us to identify what the research questions are. We were lucky, we had some QR funding, so it was quite open-ended. And then we employed a mix of traditional research methods. We did do things like surveys and focus groups, but we also used things like participatory mapping, digital storytelling, songwriting to research the issues around plastic. And one of the things we did was collect some digital stories from the community in response to the prompt, just tell us about plastic in your everyday life. And we had quite a few videos of really, you know, polluted rivers, blocking drainage channels and things. But I just wanted to play this.
Hello, my name is Kadale, and I'm here to talk about
the
plastic
importance
recycling.
of
As you
plastic.
can see behind me, there's some recycling of some different plastic from different products. One of which we can see near mafuta. So for me, I could say plastic is a magical material for me because they are all cheap, light, and easy to carry, and they are strong as well. So as from the resident who is living in a informal settlement, so learning from the nature or from scientifically proven that there's some enzymes that are found from plastic, it can really help from recycling.
So you know, that's about, I don't know what's happened. I have no idea why Keir Starmer has suddenly popped in. That's incredibly annoying. I hope we're not going to play Keir Starmer. I hope we can play the video. So that was one of the sort of examples of positive uses of plastics. And this is why we really have to solve this problem and change our relationship with plastic and go back to valuing this material and the enormous benefits and advantages that it can bring us, and stop this kind of disposable take make waste culture, which brings all these disadvantages and means that all this plastic waste builds up in the environment. At least 50% of the plastic waste we find in the environment is from single-use food and drink packaging. So it's not something that we cannot solve. I'm scared to click on that. Luckily, it hasn't worked. So these are just an example of the kind of results that we got from the surveys and the focus groups we carried out. The pie chart shows some emergent themes, what the community, changes the community wanted to see. So they really wanted more knowledge. There's no waste management infrastructure at all in the two case study sites that we worked in. And there was a total recognition of the fact that it needs to be a systems change. And these were some of the concerns that people had about plastics. So we produced a number of sort of traditional reports. We worked with Flip Floppy and some waste pickers in the communities to produce this business case of how to start your own business. We did some surveying around the delivery of plastics and sustainability education in primary, secondary schools in both countries. And there's one of the reports from Bangladesh on the far left. As well as producing those traditional research outputs, we also used our research findings to create some non-textual research outputs. And these are actually research outputs. So you can see the mural here, which is the sort of current situation in the informal settlement, and what people would like to see, and if there was a decent waste management infrastructure. And that's still on the side of a building that I was at on Saturday, and that was painted maybe 4 years ago. And sort of, it's just it's called sensitization in these environments. So it's sort of sensitizing people to the issues around plastic pollution. And we also created a song, which is to promote more sustainable behaviours. Creating music videos.
We can reduce the plastic use, we can reuse to see too. But when you recycle, the better too. Reduce, reuse, recycle. When you recycle, the better too. Reduce, reuse, recycle. Reduce, reuse, recycle. Reduce, reuse, recycle.
Drastic design wanalita plastics. Farmers walilima na intentions are.
I would say that we always work with local artists, local musicians and local creatives. I would never dream of going into an environment and kind of trying to sing or anything. It's really important. The whole point of using the arts is for social and cultural relevance. So it's super important to make sure that you're, working with people who are really properly embedded in the culture and understand all those things. And, speak the language, and they're often trusted voices in the community and all the rest of it. So it gives the messaging validity. We also created some street theatre. It's interesting actually seeing the cultural differences. So there's on the left, there's the plastic monster that was created in Bangladesh, who had an amazing script, which was basically all about, you used to love me and now you hate me. You try and bury me, but I will not let you. I will come back and haunt you. It's so powerful. And then on the right, we have the Jitu Lataka, who's the plastic monster, who resides in the informal settlement of Makuru. Again, went out into the community to create conversations around plastic waste, which become our research findings.
and I can breathe from all the smoke that is surrounding me. And I can breathe from all the plastic in the deepest sea. Reduce all the plastic bags, reduce all the metal scraps, reduce all the carbon gas, keep the air free from your pollution.
So as I say, I went back to Nairobi and we held a impact evaluation event on Saturday in Makuru. And so with the post-it notes, we're asking people some of the same questions that we asked them when we first went there. So how do you dispose of your waste? The other slide shows a piece of theatre, which is highlighting the dangers of air pollution and the toxins that are released when you burn plastic. So burning plastic is a really common way of dealing with plastic, and it's completely understandable. It reduces the volume and it stops vermin and mosquito infestations, but it releases this terrible pollution. So we were just talking about that. Now, the people that we work with have recently partnered with a local NGO to set up some bins in and around Makuru. And it was amazing to see these bins being used when I was there. I think thanks at least in part to the work that we'd already done. Moving on, another project that we're doing in Kenya is on an island called Lamu, which is just off the coast, close to Mombasa. Lamu is a UNESCO World. How am I doing for time, by the way? Oh, good. It's a UNESCO World Heritage Site where, technically speaking, single-use plastics are supposed to be banned, but enforcing these legislation is one. Legislating is one thing. Enforcing legislation is quite another thing. So there are no cars. Donkeys are a big part of the economy. They free roam to graze, and of course they go up to the waste dumps because there's food residues on the rubbish up there, and they end up ingesting a lot of plastics. So we've done a project with the Donkey Sanctuary where we've tracked the donkeys, looking at their ingestion, collected some poo, analysed it for microplastics, and then also worked with the local community about donkey welfare. And we created a play, again with a local theatre group. Importantly, they can, we've left it there. It still happens. People can still watch that play about donkey welfare and what small changes people can make to maybe make life a bit better for their donkeys. And we've just secured some more funding from the Donkey Sanctuary to establish a household level plastic waste collection pilot study in Lamu, which we hope will directly improve the welfare of the donkeys and also the donkey owners and the whole community. Oh yeah, this is a new thing. I was going to hand over to Kate at this point, but she's not here. So we're working with CCIXR at the university to develop a game, a phone-based app game, which is set in a village called Willowton. I'm not going to read through all this. You can read it yourself, but it's interesting. So you start off with a bit of money, your cottage. You can wander around the village. You go and buy stuff from the shop. You have to eat and drink to stay alive. But of course, as soon as you buy food or drink, that creates waste, and you have to choose what you do with that waste. And we're going to set up to reinforce good behaviours, etc., etc. You'll be able to buy water refill bottle at the shop, and we're going to have one water fountain in the village, but there'll be more and more water fountains as more people buy water bottles. So it's really about encouraging sustainable behaviours. Trying to move behaviours up the waste hierarchy, away from recycling, which actually is not particularly successful, and towards refuse, reduce, and reuse instead. This is the sort of early design phase of the game. I have to say it's been super interesting sitting around the table talking about how the game will work and what the priorities are and how we're communicating things. I'll speed up. So more recently, we've taken these kind of art space methods into the policy space. So we worked with a group of waste pickers. This is, has everyone heard of the Global Plastics Treaty? Yeah, okay, good. At the United Nations, through a series of 6 negotiating meetings. And we use theatre to look at the lived experience of waste pickers. There's a lot of talk about just transition in the Global Treaty. Nobody really knows what it looks like. So we developed this play and we took it to the delegates. Marcus was in the audience at one of the performances. And the play has been performed since. It's been performed to industry at Waste Picker Day. And again, we performed it at a conference last week that I've just come back from. And that was not only super informative for the audience, but also really empowering for the participants. And we used a form of theatre where the audience basically can interact with characters and ask them questions. For INC4, which is the 4th meeting, we worked with people, key stakeholders from the reuse community. So practitioners, industry, academics, and we spent about 3 days workshopping. We knew there was some confusion about reuse and refill, so we decided to create a game show and use that to kind of like educate the audience. And this is how we did it. So we had the contestants who were actually experts, and we used Slido to ask questions of the audience. And of course, this is a research activity for us. So we record the responses, and then we actually use them to pull together a policy brief. For INC5, we staged an exhibition which draws the linkages between plastics and climate, not only directly in terms of greenhouse gas emissions, but also in terms of the indirect impacts, you know, plastic pollution, blocks drainage channels, climate change causes floods. That is exacerbated by the presence of the pollution. We've now started sort of developing a toolkit of more creative ways of thinking while we're meeting. So we had a policy breakfast in collaboration with the Global Plastic Action Partnership. We just developed a different way of thinking. So it's kind of a few steps on from a flip chart, I guess, really. But you'll see people are super engaged. You know, nobody's sort of sneakily looking at their phone or anything. And people are up and they're moving. We were looking at policy enablers, I think, that session. And so the first half, we wrote down the key findings on these blocks. And then after coffee, we asked people to kind of arrange the blocks according to the priorities. And then we recently had a reuse workshop in Portsmouth, where again, we employed this kind of, we call it the washing line method, as a life cycle reuse system on the sheet at the back. And then we're asking people to kind of map policy, effective policy against the reuse system. And we could move things up and down, move things around. And again, people were kind of up and walking around. And then the report we produced, we used a sort of slightly more engaging, we used some sort of cartoon. We used some colleagues in CCI, actually, who came along and captured the meeting using cartoons. So, yeah, that's us, and this is how you can get in touch with us. And given that we're at the University of the Arts Bournemouth, it would be super nice to talk about any potential collaborations and ways that we could develop more arts in the future to help try and solve this critical issue.
Brilliant. Thank you very much. That's great. Hannah, do you want to set up? I don't know. I think we'll do questions at the end while we have coffee. All right. We'll whistle. Yeah. I got a yeah. Thank you. We'll whistle through. So I think we've got Panos, and then we'll finish up with Erato, and then we'll have coffee. Perfect. Okay. All right. So yeah. Yeah. You're good to go. Yeah. Pointers, not. Oh, there might be actually. That's one thing. Have a go. Yeah. Not twenty. Yeah, that's over here, and then yeah. So
Yes, I'm hoping.
cool. All right. Okay. Thank you. Where you go?
So, good afternoon, everybody, and those who are online with us, good afternoon as well. My name is Panos, and I'm a PhD student at the OU in my second year. And today, we're going to talk about bioplastics. It was really nice before two talks because you got a little bit of history about how plastic works and how much trouble it can cause to the environment, which include now to basically another function, which is bioplastics, and how these become artifacts in museums. And today we're going to talk a little bit about aging, care, and material identity. Now, the aim and the research is that bioplastic is the manufacture, they're increasingly incoming more in collections, like MoDiP, Science, Tate Museum as well. But the primary purpose is to degrade, right? So the really interesting question of how you preserve a material that is designed to degrade, right? So this is one of our research that we're going to answer, is understanding the conservation of bioplastics and basically study the degradation process and how we clean them and preserve them as well, right? And I'm hoping at the end of this PhD, we can actually give suggestions to museums of how to preserve these materials. Now, today we're going to talk about a specific bioplastic called polylactic acid, or PLA. Now, the materials that we tested are different. So we have, I don't know if you can see if there's a pointer. So we have granules, films, and everyday objects like knives and balls. Now, the really interesting aspect is that they're all from PLA, but they have distinct characteristic origins that can help to different types of degradation. For example, you can see they have different color. Some of them can be rigid or flexible, but they're all classified as PLA. So the first thing is how we identify them, right? How do we know if I give you something, you can say to me, it's PLA or any other different type of plastic. So interesting enough, sometimes a visual observation can be enough. For example, if you can see on the left side, the first image, it's actually tell us what it is. So it says a plastic-free bag made with PLA bio-based film. Other times, it's a little bit more about research. So we have a company name, so we have to go to find out. So while we're doing this visual observation as well, a key characteristic that you can find is the recyclable symbol as well. Now, for those who doesn't know, all plastics have a recyclable symbol, and bioplastics are number 7, which basically says other. But while you're doing this observation, you might actually see on the bottom of the row of the images some surface damage that can come in many forms of degradation, dirt, or even mold. which can also have an effect of aging that can cause also discoloration. Now, besides the visual, we use very much analytical techniques, and one of the most common that museums and people are familiar with is FTIR. It's a very common technique that we use for identifying. And here is on the screen what you see. There are different types of our PLA aspect spectra. And you can see, obviously, the specific functional groups that they have. We have the ether, the methyl group, and the carbonyl group as well. And I have to say that each type of plastic has unique pattern of pinks. So in this case, you can see all of them have the same ones. So that's why we can say, oh, this is polylactic acid. Another interesting technique that you can use for identification is X-ray diffraction. So XR or XRD that can show chemical composition and crystal structure. Now, crystal structure in a very slow term or crystallinity can affect hardness and density, right? So we can see here in the top row that the crystallinity aspect can be between 10 and 30. Now, it's very important to say that if you can see some peaks there, if the peak is smaller or it's not as prominent, the polymer is basically less crystalline, so it has more amorphous, that means it's more elastic. If the peaks are high and very intense, the material is more stiff and hard. So for example, if you have a film, it's elastic, but if you have, for example, our knife, it's hard. A really interesting aspect besides the crystallinity, like I said, is the chemical composition. So in our pellets, we can see that it's very amorphous, between 10 and 30. You only see a small, slight peak. But in our film, we see that's a more structure. So you see a big peak coming between 10 and 30. However, interesting enough, on the knife, you see other peaks as well. That represent the presence of an inorganic material that was infused to the polymer chain as well, which we so far analyzed further to know how affecting the bioplastic and what is that inorganic material as well. Now, moving on, I would like to talk about, okay, there are some other ways, but one of our other projects is how to preserve. And one of the ways to preserve them is to clean them as well. So we're going to talk about a little bit about the cleaning strategies. Now, there are many ways, which one of them is chemical cleaning. But before we jump to in all the chemical cleaning, what we did is what we call a spot test. It's for ethical consideration, because in museums, you don't want to damage the objects. So what we did is we took a droplet, as you see in the video, and we drop it to see what immediate effect will have on the object as well. And it's very important to say that we use conservation grade materials and chemicals, as you can see on your screen as well. And we use Hildebrand solubility parameters. To explain that is you see that they have specific numbers. And what that means is if polylactic acid has a solubility parameter of 19.9, so if a chemical is closer to that number, it's more possible to dissolve, degrade it, right? So it can be more effective to cleaning any type of dirt. And the further away it is, it's less damaging to the object itself and may or may not remove the dirt as well. So we did a solubility test about 5 hours, and we see some visible degradation on our PLA samples, especially in acetone, and confirms our theory and solubility parameters as well. If you remember in the previous slide, 19.9 was PLA and 19.7 was acetone, so they're really close. As you can see, we have immediate change within 5 minutes. So we have a chemical degradation, self-alteration, and discoloration of the PLA film. So basically from clear became white and then became brittle and stiff. So one aspect that that can affect is the crystallinity, like we mentioned before. So the theory is that because the film is less crystallized, so it's more amorphous, acetone can penetrate better and degrade the product, leaching out some of the aspect, like plasticizer. Plasticizer is something that they use in products to change some of the parameters, for example, make attributes like more elastic or clear. That's why we see some change in color as well. While the knife, on the other hand, which was more crystalline, if you remember the graph, didn't have S degradation or damage visible as well. To confirm that, we ran another X-ray diffraction. So it's very clear when you see the film how the peak on the crystallinity region has changed and become more prominent. That means basically the amorphous region partially degrade or dissolve and became more prominent, which means is resulting in increased crystallinity detected by the XRD as well. On the bottom row, you see of the knife, you see there's no much difference. That happened to the PLA film is that it changed color, right? So that was really interesting to us, and we wanted to quantify how's that changed. So in order to do that, we did some colorimetry measurements. So basically, colorimetry is the quantification method of measuring how the color has changed due to degradation. And in order to do that, we use a color space called CLab. It's used both in industry and in conservation as well. That includes 5 different axes. So we have the L, which is basically light from 0 to 100, 0 black, 100 total white. We have the B axis that in positive as green, minus is blue. And then we have the A axis, which is plus red, minus green. You can see also for everyone the primary colors, right? Just to. And also another thing that I would like to point out is after we do the measurements, there's a value called delta E. So the delta E is the distance between the colors. The bigger the distance, is the different perception that we have. So the numbers can be between 0 to 100. And as you can see, if the value is different, the perception of the color can be different as well. It's really interesting. So here are measurements. In the top graph, you see our values, which is L, A, and B. Now, what's really interesting is that the film in the 5-minute time that became from clear to white, have an increase in the B value. However, the PLA knife had really minor changes, so it was less than 1. And now on the bottom, as well, you can see the delta, the E values, how they change, and how from 0 to 5 minutes, it went above 4. So if you remember the previous that has the graph, it basically, if it's above 2 to 10, it's noticeable from glance. And if you see the picture clear to white, it's very noticeable change as well. While the knife also, it was initially less than 1, but after 98 minutes, it became for more clear white to more opaque white. And it's also confirmed by the calculation as well that's became. Yeah, above 1. So concluding, basically our analysis, we have in the FTR about the degradation, we have minor group stretches, we have the form of new peaks that basically says the degradation byproducts that we're having. We have the carbonyl stretching, which also, the carbonyl stretching basically about the crystallinity aspect. We also confirmed it with XRD. And basically what we see is that methanol, we have increased epicity, acetone, we have significant, and ethanol, white spirit, and distilled water, we don't have significant damage. What does that mean? Well, what that means is that solvent selection can help maintain PLA's visual stability and mechanical properties, and also appropriate solvent protocols can mitigate risks presented with artifacts, integrity, and longevity. Another cleaning method that we use, and I'm going really quick about it because I don't have much time, is that we use gels and surfactants because we want to also promote some green chemistry as well. Now, based on the knowledge that we have, we use conservation grade surfactants and gels. We can see on the list before. And what's important is that the gels can be either use soft gels and hard gels meals that you can take a piece and use it with abrasion techniques. That's the difference is. And now we do test with two parameters that we create gels in distilled water for standard rider, and then we use with ethanol as an additional testing to evaluate effects on performance as well. Now, really quick, the first thing that we said we're going to do is test it on some stains. Now, on your left side, you can see some watermarks, and on the bottom, a fingerprint. And then on the right side, you see the clear surfaces as well. Now, we did some analyzing as well. So, for example, we analyze the water because it was a tap water. So, as you know, tap water can contain some minerals as well. So, we did some semi-DX analysis. Semi-DX pinpoints and tell some inorganic. So we found that tap water contains, especially Milton Keynes, calcium, chloride, sodium, and magnesium as well. That means a really hard water. That's why you see the surface of the water droplet as well. And the results were that based on topographic analysis as well, we were able to quantify the percentage of success. And all in all means that we have some ineffective gels, which the soft gel, Safam and Clusel, only 70 to 85% success rate. But our agar and gelagam, our hard gels, had 100% success rate due to the rat's inability to use gentle apply with friction, like rubber. Now, our jets in ethanol, however, had 100% success rate, which is not surprising as well. And our surfactant as well had effective removal of watermark and fingerprint stains. Really quickly, again, we're going to move to other bioplastic as well, like PCL, which is a bioplastic from petroleum source, and starch, another bioplastic base. We obviously know, and we do 3D printing as well, about environmental aging and cleaning. We do adhesion testing, nano-indentation, which is more of the engineering side, and analysis of chemical leaching from bioplastics. And hope, again, that the outcome will be materials that specify for conservation analysis and help the museums understand these materials as well. And another thing that also everybody mentioned, we do have an ongoing public engagement. We are basically going in a survey, and I'm really glad I'm here today. Thank you for the opportunity as well, because it will be a great asset of us if you scan this QR code and do our survey. And if you have any question, it's purely anonymous. And the only personal question is your background that will lead you to a specific survey depending on your skills as well. And hoping not too much time. That's me.
Good. You're good.
Oh, good.
Thank you. That's really good. Thank you.
Yeah, sure.
Really good.
Yeah.
I love the gel. That's great.
Sorry?
I love the gel. I love the gel. Yeah. So we've got our last speaker before we take coffee, and I think let's do the questions then, if that's all right, over coffee, should we? Yeah.
I have additional slides.
Huh?
It's additional slides. Hey, Panogiotis, what's that?
That's if someone has a question.
Oh, he's
Sorry.
organised.
I had about like 40 more.
Oh, okay. Let's go fast then.
I think you have to go fast.
Okay.
Now, that's 3D printing if you want.
Ding, 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 ding.
Yeah, there's a lot more.
Sorry, that's good. That's good. Right. I would like to welcome Dr. Erato.
So, hello, everyone. I'm gonna be very, very fast. I know that you need a break and a coffee, so don't worry. So my name is Erato Kartaki. I'm a research fellow in heritage science here at the Plastics Research Center. Ta-dan, ta-dan. And my background is in conservation of antiquities and works of art. So today I'm going to talk about how plastics, the research center that we are here today, supports the cultural heritage. So more or less, Christian said a few things about this before, but now you're going to see it with images. So we are at the Arts University Bournemouth, and a few years ago, the Innovation Studio opened here. You heard already about the MoDiP Museum from Louise, and 2 years ago, I think, you applied for the funding at the UKRI and was successful. And here we are with plastics today. We have a funding for 5 years, and we hope that we'll be able to continue also after that. So what are we doing here? Our mission is to develop and disseminate knowledge for the benefit of heritage, design, and the future sustainability of plastic products, and help develop new knowledge for museums and manufacturing industries about plastic materials. So, as you all know, plastics last forever, right? No answer? Great. Well, let's see. Do they? No. So this is, of course, a very good rumor that the plastic companies created after, I think, the Second World War, saying, oh my God, plastics last forever. Let's go with plastics. Well, as you can see, for 3 examples here, this is not true, especially with synthetic plastics. Who mentioned that before? That someone was from here, that the plastics, they want to go back to their first, how they used to be. So that's why also they degrade. It's not like other objects that we know in art. So usually the plastics material, especially the synthetic ones, last from 5 to 35 years, depending on the type of the plastic. And why is that a bad thing? I mean, we have seen other works of art that they degrade and we say, oh, come on, it's beautiful, it's authentic, and yes, it's very expensive because it's that old. And we can see that from, for example, patina with oil paintings. Unfortunately, this is not the case with plastic materials. The degradation gives a negative effect and they lost their value. So from one hand, we have the unpredictable degradation of plastics, and on the other hand, the limited conservation knowledge. And this is where we hope to come and fill the gap. So for cultural heritage is to understand the degradation mechanism of historic and contemporary plastic materials, to develop and disseminate knowledge to preserve and conserve plastic artifacts, and innovate in the use of additive manufactured plastic like 3D printing materials for museum and conservation use. So we have like 2 different topics. Use whatever word you want to do. So anyway, cultural heritage, preserving the past. This is how we say. So we do tailored material analysis on plastic artifacts, and we provide also conservation recommendations for evidence-based decisions for display, storage, and cleaning of plastics. And on the other topic, we want to explore the future. We want to understand how the plastics age. So we're studying the aging and mechanical properties of contemporary plastic materials, like 3D printing materials. We review their aesthetic properties, like texture and color, and we hope that we can help artists to select the appropriate plastic material, depending on what they want to do for their work of art, what the outcome they want to be. We also plan to do some educational programs like online mini courses and workshops on conservation and preservation of plastics, summer school for conservation students and curators, and hopefully a master degree on conservation of plastic heritage. So this is our lab. So some of you have already seen that because you came earlier today. We opened officially, was it 29th of January? So like 5 months ago. Do I do the maths right? I'm not so sure. So yeah, we opened officially late January. And part of our equipment and what we can do is material characterization, as also Panos mentioned before, is the FTIR. We have one at the lab, and we are getting the portable one soon. It's on the way to do to identify different type of plastics, and hopefully with the portable one, we won't need also any samples. Good for museums. We can see the mechanical properties of the materials and do mechanical tests. And we have the digital microscope also to see the surface, to understand to see the surface of the object better. And we have equipment for gloss measurement and color identification. And we have 2 chambers. I'm really sorry, I forgot to take a picture of the other one. I remember last night, but yeah. Anyway, so we have the weathering station, so we can do tests with UV, water, and temperature, and do also accelerated aging tests with a different temperature and relative humidity, like the auto test for cultural heritage views. We also provide advice and research for collection care and preventing conservation, like condition reports, advice for display and storage, environmental monitoring, and advice on handling, packing, and moving. And we also started a few projects. So this is something that we starting recently, and it's about the evaluation of plastic 3D print materials for cultural heritage use. So we want to identify suitable materials for museum use and restoration practices, and understand the sustainability of this method, like the additive manufacturing restoration method. So at the moment, we are at the chemical stability. We're checking the chemical stability according to museum standards using the audit test. Yesterday, we took some results. Pano, I would say, think about the PLA again. This is all I have to say. Just, yeah, think about it. We are planning also to do mechanical tests on strength and flexibility and evaluate the aesthetic outcome, the color, the surface, texture, and reflection. Another project that we started is with MoDiP about the material identification of erinoid plastics to identify the exact type of the plastic material and to improve the collection's information. And I can say officially that today we started a project with the Bill Douglas Cinema Museum. We have Matt and Chris with us today, and they brought some objects from the museum. This is a pilot project from us about the identification of different plastic materials on museum objects. And we hope to help them understand about appropriate conservation treatments, preventing future degradation, to ensure safe storage and display, assessing risks, and understand the history of the objects. We hope. So, and one more project that we're planning for the future is about solvent interaction with plastics by using nanomotion imaging. And the aim is to systematically assess the impact of solvent of different type of plastics and generate practical guidance for conservators on cleaning and caring for plastic heritage materials. So more information. Do I have to click? Yes. So more information about our research center you can find on our website. Yeah. So we have also the contact us form where you can send any requests, any questions. If you like collaboration with us, go up. And you can see about the project, meet the team, and research that we're doing and the services that we provide. So thank you for your time. and it's time for coffee.
Thanks very much. Thank you very much. Thank you for those online. Appreciate that. And there's the links. Hope you enjoyed it. Thank you.